So the last three classes, we've talked about three different ways of solving systems of equations, either by graphing, by substitution, or by elimination. And now we're gonna take a look at systems and decide, okay, which of the methods will work the best. And then we will solve the systems from there. All right, so some things that may be helpful in deciding which method to use. So as it says at the top, the essential understanding, you can solve systems of linear equations using a graph, the substitution method, or the elimination method. The best method to use depends on the forms of the given equations and how precise the solution should be. For graphing, it's best to use only if both equations are in slope-intercept form. So if both equations are in that y equals mx plus b form, that's the only time I would use graphing. For substitution, and I would change this a little bit, I would use substitution when only one, or when only one equation, actually maybe not, is solved for a variable. So either x equals or y equals. Now, if they're both in that y equals form, I would probably use graphing. But if they're both in x equals, or if only one is in either x equals or y equals form, substitution works the best. And then elimination, there are really two times or two different situations where elimination would be used. It's easiest if we have a variable with coefficients that are exactly opposites. That's the easiest way to use elimination. However, another time when elimination can be used is when it's not convenient to graph or use substitution. Elimination kind of becomes the catch-all. It can be used with any system. So if you're not going to use, so this is kind of the way I would go through this. I would look at my system, are both in that y equals form? If so, I'm going to graph. If not, then I check, is one equation solved for a variable? If not, or if it is, then I'll use substitution. If not, then I will look at elimination. And then if I'm not using graphing or substitution, I'm going to use elimination right away. Give me one moment. I have a animal that's needing some attention. All right, so this first couple of problems, all we're going to do is determine whether we should use substitution, elimination, or graphing to solve. And what I'm going to do is make a poll. So for this first one, we're looking just at letter A. Would you use graphing, substitution, or elimination? All right, I was going to add a poll. I don't know if it, there it is. All right, so go ahead and vote for letter A. Which method would you use? Waiting for 3 more voters. Waiting for 1 more voter. All right, so if I look at letter A and I consider that table that we just had on the previous page, are they both in y equals form? Now let's see, I have negative 2x minus 5y equals 2. That's not y equals form. So they're not both in y equals form. I wouldn't use graphing. In fact, if I did try to use graphing, I would have some fractions for my intercepts, and it would be difficult to get an accurate graph. Is at least one of them in either x equals or y equals form? The first one is not. We already took a look at that. The second one is not. So I probably wouldn't use substitution. Now that doesn't mean you can't. It just probably wouldn't be the most effective. And then so if I'm not using graphing or substitution, I would use elimination. And then you see we're not going to actually solve that one. All right, the second one. Should I use graphing, substitution, or elimination? 2 more votes needed. All right. So in this case, again, if I look, they're not both in y equals form, so I would not use graphing. My second one is in that x equals form, so I would probably use substitution. Could I use graphing? Could I use elimination? Yes, but they're going to be a little, there's going to be some work that needs to be done before you can use either of those methods. So just going to jot down here elimination. Ooh. Try that again. And substitution. All right, third example. So this is letter C. Again, would you use graphing, substitution, or elimination? And you should see the poll now and go ahead and vote. All right, everyone has voted. And I agree with the majority. The majority of people said for this one, they would try graphing. Again, they're both in that y equals form, slope-intercept form. So it would make graphing kind of a logical choice. The other method that received votes was elimination. And yes, again, you could use elimination. It's actually, if you did elimination, you'd end up with 0 equals, and then everything else would be on the right side of the equal sign, which is fine. You know, you'd have some fractions when you combine the 2/3 x and the negative 2x. But again, you could certainly use elimination with that method. It just may not be as quick or as easy as graphing. All right. Now we're going to choose the method and find the solution. So now we're going to do both. So let's determine our method first. So again, which method? And whichever method comes up most popular, we'll do that method. And if it's not the most efficient, we'll see why. All right, we've reached a majority. So in this case, substitution came out with the majority of votes. So we're going to use substitution. Oh, what happened there? So I agree, substitution is going to be a good choice because our second equation is in that x equals form. So I am going to substitute y minus 16 in for x. Distribute the 10. I have y's on the same side of the equal sign, so I'm going to take my 10y plus 9y. That gives me 19y minus 160 equals 11. Add 160 to both sides. Divide both by 19. And I would probably use a calculator to divide that. 171 divided by 19, although there are some clues that would lead you to know that it's 9. The only number that if I multiply by a number ending in 9, that'll give me an answer of 1 is 9. So y equals 9. Then check or find the x value. So I get -7 and 9. Easy for me to write. All right. Again, for this one, I'm going to have you choose which method, and then we will solve by that method. So go ahead and vote. All right, with 10 people voting, we have a majority, and the majority is for graphing. I would agree with that. They're both in that y equals form. So I would use graphing because they're both in the y equals form. This is actually one form that you could use any of the three. Again, just being careful. But if we graph, again, this first equation, the y-intercept is 6. The slope is -4. So down 4 over 1. Again, on the homework, if you are graphing, you can make the points on the graph just by clicking. You don't have to actually draw out the points. But then drawing the line, obviously you would draw. The second equation has a y-intercept of -3. And a slope of -1. And that's when I think you probably could see, as I made the points, where they crossed. And 3, -6 would be my solution. Next example. All right. Which method would you use? And then we'll use that method. Go ahead and vote. All right. Again, we have a majority. And the majority chose elimination. Sometimes I think some of you just click one just to click it, but maybe not. Because I don't have any of the equations in either x equals or y equals form, we wouldn't use substitution. And again, they're not both in the y equals form. So graphing, you could use graphing. Again, you would just have to do a little bit of work in order to graph. So I think elimination would be our best choice. And in this case, I think I can use elimination if I multiply the bottom equation by 2. That'll give my x's opposite signs. So yes, there is a little bit of work if you're going to use elimination. Remember, we're multiplying everything in that bottom equation by 2 and adding. -6x plus 6x, 0. -10y plus 10y, 0. So I know as soon as, if I'm using elimination, as soon as I get 0 on the left-hand side, that's going to mean either infinitely many solutions or no solutions. And it all depends upon what happens on the right-hand side. In this case, -30 plus 30 is 0. So we get a very true statement. 0 is equal to 0, giving us infinitely many solutions. All right. What I'm going to do, there are 2 questions for you to try. I am going to actually copy the second one back to the previous page. So that they can both be on the same page. So what I want you to do is decide what method you want to use to solve them, and then go ahead and solve them. Once you have them solved, so once you solve number 1, please go into the chat and let me know which method you used and what your solution was. And I'm going to give you 5 minutes to take care of those 2. And then we will talk about answers after that. All right. So for number 1, which method would you choose? I would say I'll check the chat, but the chat is empty. So go ahead and unmute and just let me know which method. Graphing, elimination, substitution. Those are your choices.
Elimination.
Someone said elimination. Was that you, Jacinta?
Yes.
All right. I like elimination for this one because, again, they're not both in y equals. Neither of them are in either x equals or y equals. So I'm a fan of elimination with this one. This one is kind of like the last ones that we did with elimination. I can't multiply just by one value or one equation. So what I would do, I'm going to eliminate the x's, and I'm actually going to multiply by 3 and 2 because that will give me negative 12x and a positive 12x. You could multiply by 6 and 4. You could multiply by 4 and 5, just depending upon which variable you wanted to eliminate. And if you notice that you could multiply to get to 12 instead of having to go all the way to 24. So multiplying through by 3. Negative 12x plus 15y equals 0. The bottom equation multiplying through by 2, 12x minus 8y equals negative 28. The negative 12x and 12x, they cancel out. 15y plus negative 8y is 7y. Equals negative 28. Divide by 7 for y equals negative 4. Now, before I move on, if you would have multiplied by 6 on the top and 4 on the bottom, you excuse me, you would have ended up with 14y equals negative 56. And then when you divided both sides by 14, you would still get negative 4. So the number you multiply by doesn't affect the answer. Okay, as long as you get one of the variables to be eliminated. I'm going to take that negative 4 and plug it in to one of my two equations. I'm going to plug it into the second equation. Whoops. Six x minus 4 times negative 4 is positive 16. Then I'm going to have to subtract that 16 from both sides. And divide by 6. So my solution that I came up with is negative 5, negative 4. And again, I'm going to plug into that first equation to double check. So negative 4 times negative 5 plus 5 times negative 4, does that equal 0? Negative 4 times negative 5, that's positive 20. 5 times negative 4 is minus 20. And 20 minus 20 is 0. That checks. All right. For number 2, excuse me, which method would work the most efficiently to solve this system? In this case, it looks like substitution. I have one of my equations solved for y. So I'm going to take the 4x minus 4 and plug it in for y in the second equation. Distribute the 2. So negative 8x. 2 times 4x is 8x. 2 times minus 4 is minus 8. 8x, negative 8x plus 8x, that's 0. So I have negative 8x equals 5. Not a true statement. So there is not a solution, no solution. All right, any questions?